Electrical symbols are used on home electrical wiring plans in order to show the location, control points, and types of electrical devices required at those locations. These symbols, which are drawn on the floor plan, show lighting outlets, receptacle outlets, special purpose outlets, fan outlets, and switches. Dashed lines are used between symbols to denote which switches control specific lights or receptacles. These are quite a few symbols used to represent the devices used in home electrical wiring, but some of them are very similar, so care should be used when working with them. An outlet is any point in an electrical system where current is routed out of the system in order to supply power to electrical equipment. An outlet is usually a receptacle outlet or a lighting outlet. A receptacle outlet is one in which one or more receptacles are installed for the purpose of attaching plugs or cords connected to the system. A lighting outlet is one intended for direct wired connections to a lamp holder, lighting fixture, or ceiling fan. Special purpose outlets also exist. These may be dedicated to specific types of equipment such as a furnace, oven, garbage disposal, or other similar pieces of equipment. Electricity is supplied to a house through a service entrance panel, also called a load center, where circuit protection devices such as circuit breakers or fuses are located. Electricity is then distributed throughout your home using branch circuits to provide power to appliances and lights through receptacles, switches, and fixtures. As of the 2011 National Electric Code, most new replacement receptacles must be tamper-proof. This requirement is designed to protect small children from injury by preventing the insertion of objects other than electrical plugs into the receptacle contacts. Some exceptions to this requirement include wall receptacles that are more than 62 inches from the floor level and large appliance receptacles that are located out of reach. An old switch can be replaced with the same type, or you can change a single pole switch to a rheostat dimmer if it controls approved lighting fixtures. Older switches may not have a grounding terminal, and there may be no ground wire present in the switch box. In these cases, if it's a grounded metal box, the grounded terminal on the new switch should be connected to it. Otherwise, a non-conductive faceplate should be used to avoid direct contact with the metal on the switch when operating the lights. New wall receptacles and switches will have two types of contacts: terminal screws on the sides and holes in the back. Straight wires may be used to connect to these holes in the back. The holes in the back of the device are used for inserting straight wire into the internal clamp. The holes will be labeled to indicate what wire size can be accepted. Both switches and receptacles are available in 15 and 20 amp circuits, so be sure to use the proper size replacement device for the circuit you are working on. In older dwellings, the devices and wiring may be outdated, and you'll find receptacles that are ungrounded or even ungrounded and non-polarized. Always use an appropriate type of receptacle to replace the existing one for replacement. For instance, don't replace an ungrounded receptacle with a new grounded one if no ground wire is present. There are three basic types of wall switches you will encounter in most situations. A single pole switch is the most common that you will find and can be identified by two screw terminals, and in the case of new switches, a third one for ground. The second most common type of switch found in residential buildings is a three-way switch. These can be identified by 3 terminal screws, and sometimes the newer versions will have a 4th green screw for connecting a ground wire. A 3-way switch is used to control lights from 2 locations, like the top or the bottom of a staircase. Other switches you may find in the home are a 4-way switch. These have 4 terminal screws and a 5th green one for a ground wire. 4-way switches are used between 2 3-way switches to control lights from 3 or more locations. This can be handy if you have a large room with several entrances requiring light control from multiple locations. This is a standard 15 amp 120 volt wall receptacle outlet wiring diagram. This is a polarized device. The long slot on the left is the neutral contact, and the short slot on the right is the hot contact. A grounded contact at the bottom center is a crescent-shaped hole. Don't use this receptacle when no ground wire is available. The hot wire screw is usually brass in color. The neutral screws are usually silver in color. The ground screw, of course, is usually and always green in color. This receptacle can be found in the living room, bedrooms, and other wall outlets. One of these may be controlled with a switch and/or wired to other outlets in the circuit. For a 15 amp receptacle like this, 14-2 cable with a ground should be used to feed the circuit. A 20 amp 120 volt duplex receptacle outlet like this one should be installed in circuits using number 12 AWG cable and a 20 amp circuit breaker. These receptacles are usually found in kitchen wall outlets where 2 branch circuits are needed to serve small appliances and a refrigerator separately. When using this device for heavy appliances like washing machines and microwaves, it should be connected to a dedicated 20 amp 120 volt circuit breaker. As of 2014, a ground fault circuit interrupter or GFCI receptacle is now required in a laundry room for a washing machine. A GFCI stands for ground fault circuit interrupter. It's a device designed to protect against electrical shock by quickly shutting off the power to a circuit when it detects a ground fault or leakage current. Essentially, it monitors the flow of electricity in the circuit, and if it detects that the current is flowing along an unintended path, such as through water or through a person, it trips to prevent electrical shock. You can find GFCIs in various locations where electrical outlets are used, especially in areas where there's a higher risk of electrical shock due to moisture or proximity to water. Common places you'll find a GFCI include bathrooms, kitchens, laundry room areas, outdoor outlets, and near swimming pools or hot tubs. They're crucial for ensuring electrical safety in these potentially hazardous environments. Some electrical codes require circuits to be protected from arc faults. These can be accomplished with the use of AFCI breakers. Arc fault circuit interrupters, or AFCIs, should only be installed by licensed electricians, as their installation involves working with electrical panel boxes that are usually live. Properly installed AFCIs should also preclude the possibility of nuisance tripping, which can sometimes occur when an AFCI activates in a situation that is not dangerous, causing an unnecessary or needless power outage. As the title screen of this video suggested, this is the first installment of my DIY house circuit layout and connection series. In this series, I'll be covering essential topics to help you understand and manage your home electrical system safely and efficiently. This video started by the introduction of the broad subject of panel wiring, connections of duplex receptacles, GFCIs, and arc fault circuit interrupters. By the end of this series, you'll have the knowledge and confidence to tackle your own electrical projects and ensure your home's electrical system is safe and running smoothly. Future topics to be covered will include panel wiring. Learn how to properly wire your electrical panel, including identifying circuits, connecting breakers, and ensuring proper grounding. Receptacle connections. Understand the wiring and installation of duplex receptacles, GFCI receptacles for added safety, and AFCIs to protect against electrical fires. Appliance receptacles. Discover how to wire 20 amp, 30 amp, and 50 amp 240 volt appliance receptacles for various household appliances. Light switch wiring. Master the basics of wiring light switches, including single pole, 3-way, and 4-way switch configurations for controlling lighting throughout your home. Stay tuned for up-and-coming videos where I'll dive deeper into each of these topics, providing step-by-step instructions, safety tips, and troubleshooting advice to help you successfully complete your DIY electrical projects. Don't miss out on future installments of my do-it-yourself house circuits, layouts, and connection series, and empower yourself to take control of your home's electrical system.